Let's do a confidence interval problem that involves with a T procedure. A group of renewable energy researchers is trying to estimate the average waste in pounds generated by residents in an urban city per day. Unfortunately, the population variance is unknown, so you don't know sigma squared. That means you don't know sigma. Then this is a T distribution in a random sample of 25 adults. So n is equals to 25. So followed by the 25 adults, we have the sample mean and sample standard deviation. So x bar is equals to 5, and then the standard deviation is equals to 1.5. So we already answered the first part, so that is a T procedure because sigma squared is unknown. And then in part B, I am asked to calculate a 95% confidence interval. Since no data is provided, then this is a stats problem. So where do we find the T interval? We go to stat, and then we go to test. We use start and edit, right? And then you go to test, and then you use the T interval. So the T interval, should we do the data option? No, because we don't have data at all. So we pick the stats option, and then the x bar is equals to 5. Okay, for some reason my mind is not responding. So let me go back and then go in again. So and then we select the T interval, stats option, and then the first one is 5. Now it is working. Okay, and then the S is 1.5. and then the sample size is 25, and then the C level, the confidence level is 0.95, so everything is good to go. And then all you have to do is you calculate, right? So you calculate, so the lower limit is equals to, let's keep one decimal place, so that will be 4.4 and then 5.6 pounds, right? How do we explain that? So we are 95% confident that the true average waste, what is true average? True average means the mu, the true mean, true average. Waste in pounds generated by residents, right? I forgot to type the word by. Generated by residents in that urban city falls between 4.4 and 5.6 pounds per day. What does that mean? That means we are trying to find what the true mean is. And then we are 95% confident that this mu is between 4.4 and 5.6. But we will never be able to find out what mu is. Again, confidence interval is an inference method. We are trying to guess the mu. We are not trying to find out what the mu is exactly. All right, so this is the end of B, and then in C, we lower the confidence interval to 70%. But before we get into that, I know some textbook, they would like to break this down into little steps. So for example, they would like to ask you to plug it in. So the x bar plus or minus half alpha degree of freedom, and then s divided by square root of n, right? So the x bar is equals to 5 plus or minus, we don't have the T, and then the S is 1.5. The sample size is the square root of 25. So how do you find the T? So to find the T, first you draw a T curve. I know some textbook and some online homework, they ask you to sketch the graph too. So this is a 95% confidence interval. So you cut 95% right in the middle, and then your alpha is 5%, right? So this will be 2.5%, and then this will be 2.5%. So which is 0.025, right? So you have a T right there, and then you have a T right there, and then the degree of freedom is equals to, not n, the df is equals to n minus 1, which is 25 minus 1. So to find the T, you have to do inverse T, and then you do half alpha, 5% divided by 2, and then the degree of freedom is 25 minus 1. And then you do this in your calculator. So you go to second vars, and then you select inverse t, and then you do 5% divided by 2. The degree of freedom is 25 minus 1. So that is the t value that you are looking for. So 2.063. So you put 2.063 right there. I know some textbook they ask you to do this, and they also ask you to shade the area as well. But if you are using a TI83 Plus, you don't have inverse t, so there are two ways to solve this problem. Either you program it by yourself. So if you watch one of the previous video, the one before this lesson, I have a screenshot that shows you how to program the inverse t to your TI83 Plus step by step. Or if you are taking an online class, all the works can be done online. You can go to Google and then look it up. Just search for inverse t distribution calculator. I am sure there are plenty of free websites, and they offer you a free access to the inverse t calculator. Okay, so and then you compute this. That will give you the lower limit and the upper limit I got from the calculator. So either you use the calculator to get it out in a few clicks, or you do this step by step. So when you do a homework, I know you can use your calculator, but the person who wrote the problem would prefer you to do this in step by step style. Make sure you know how to do both. And then what other than that, sometimes they ask you to calculate the margin of error. So this margin of error, ME, or sometimes they call this error bound. What is the error bound in this problem? So that will be 2.063 times 1.5 divided by the square root of 25. So the error bound is equals to 0.6189. Okay. So that is now the end of part B. Let's move on to part C. So in part C, they asked me to calculate a 70% confidence interval. So that will be the x bar is still a 5, and then plus or minus. So the only thing that is different is the t, right? And then we have a 1.5 divided by the square root of 25. And then first, let's use the calculator to do it. So stat test, and then a t interval. And then all you have to change is you change the C level to 0.70. Okay, 5, 1.5, 25, 0.70, so 70%. Then we have 4.7 and 5.3. Okay, and then what about the t? So the t, let's get the t. So the t is equals to half alpha, and then degree of freedom, by the way, alpha, so this time is 30%. So this is what you have to do. You have to do the inverse t, and then you take the 30% divided by 2, and then the degree of freedom is 25 minus 1. So the degree of freedom is 25 minus 1. You go to second vars, and then you select the inverse t, 0.30 divided by 2, and then 25 minus 1. So there you go. That is equals to 1.059. Okay, so if you make a quick comparison, the previous t is 2.063, and then this one is 1.095. So we can clearly tell then this will be a shorter interval, right? So let's do make a quick comparison for a 95%. So for a 95% confidence interval, we take the length is equals to the upper limit minus the lower limit, and then for the 70%, we take the length is 5.3 minus 4.7. So this is equals to 1.2, and then you take the 5.3 minus 1.7, minus 4.7, that is equals to 0.6. So that tells me the 70% is shorter, and then the 95% is longer. Why? Because the 95% has this one is longer because higher confidence level gives you a higher t, and the higher t produces a larger margin of error. So that's why you get a longer interval. And then if you lower the confidence level, so lower the confidence level, then you have a smaller t, so that gives you a smaller margin of error. So as a result, that gives you a shorter interval. All right, so that's how everything works. And then if you want to make a quick comparison, so let me just do it in another color. So let me do it in orange. So this t is what? 2.063, right? So that is for the 95%. For the 77%, do we agree that the centerpiece is smaller? The centerpiece, maybe it is just like right here to give you a 70%, right? This piece and this piece, that gives you a 70%, right? So the 70%, the t will be right here. And then you have the 0 right in the middle. So since the orange t is closer to a 0, that means the orange t must be smaller than the yellow t. So that's why you have a smaller t. The smaller t gives you a smaller margin of error. So overall, you have a shorter confidence interval. This is a very good problem to be put on a test. So if you have a test coming up, be sure you study this. So they must put this on a concept check or in a multiple choice. All right, and then let's move on to part D. And then part D, I want to raise the sample size to 250. So let's do D right here. So now n is equals to 250. I want to compute the confidence interval. And then this is based on part B. So part B, they asked me to do a 95%. Okay, let's do that. Second vars, we go to second mode to quick, and then we go to stat test, and then we do a t interval. So t interval, we have to change the sample size then. So the sample size, we have, instead of 25, you have to change that to 250. So 250, and then make sure you are doing a 95%. Look at my calculator. Make sure you enter the same thing. So 95%, 250. So that what is that equal to? Calculate. So that gives you a 4.8 to a 5.2. So what is the length? The length is 5.2 minus 4.8, right? So the answer is equals to 0.4. And then what about the length in part A? Here, that was a 5.6 interval. That was a 4.4 to 5.6, and then this one is n equals to 25. This is n equals to 250, and then the length is 1.2. So it looks like when you reduce the sample size, you reduce the length too. Why? Here, the formula is x bar plus or minus t times s divided by n, right? So the magic is right here, the n. So all you have to think about is, what is my my s right here? The s is equals to 1.5. So how about this? 1.5 divided by, make this simple, 1.5 divided by 10 versus 1.5 divided by this. Which one is smaller? The answer is the one with a large denominator is very small. Okay, when the denominator is huge, the overall fraction is small. So when you raise the sample size, you just make the s divided by n small. Okay, so here is my conclusion. For a big n, then you have a small fraction, right? And then that gives you a small margin of error. As a result, you get a short confidence interval. If you use a small sample size, then you get a bigger fraction. As a result, that gives you a bigger margin of error. As a result, that gives you a longer confidence interval. And then this is also a very popular exam question. Be sure you study this when you do your homework and when you study. So that is the end of this problem. If you think my instruction is helpful, let me know in the comment section below. As always, like the video, subscribe to my channel, share the video for me. Appreciate your help. I still have one more problem to cover in the next one. I see you all in there. Signing off for now.